So in this, we have to find the heat of fusion, the latent heat of fusion in descending order.
Yeah.
So Q is for material X, Q is 200 joule and M is 4.
Okay. So first, what should I write the formula?
Q is equal to ml.
Okay. Now.
So now we have to find L. So Q upon M.
Perfect.
200 upon 4.
Perfect. So what will be the answer?
50.
So L of X will be equal to 50 unit.
$50 joule.
Joule.
Joule per kg.
For Y.
For Y, 300 upon 5.
So
That
what
is
will be the answer?
60. That is 60. 60 joule per kg. And then 300 joule upon 6 for Z.
Perfect. So what will be that answer?
50 joule per kg.
So now what will be the final answer?
So Y is greater than X is greater than
Latent
Z.
heat of Y
is greater than X is greater than Z, because they both have
These both
same.
are equal, no?
Okay, then equal. X is equal to Z.
Tanisha, you have joined? Okay. Next step. Try down this one. Tanisha, you give the answer of this quickly.
A refrigerator converts 100 grams of water.
Yeah.
Heat given by the refrigerator. 100.
Okay. So what should I write first step?
Q is equals to MC delta T.
Okay. Formula is Q equals to MC delta T. Okay. Next.
So 100 gram.
Okay. First Q will be what? Total. What will be Q then?
100 into 4.2 into.
Matlab, heat lost by
Refrigerator.
By water plus what will be the next?
Latent.
Latent
Heat.
Okay, so what should I write? Change in phase, no? Change in phase.
Yeah, change. 100 into 336.
So water to ice, correct? Next. And what will be the temperature in this case? Heat lost by water. Tanisha, quickly. Azra, you just tell me the final answer if you get.
Oh, okay.
Okay, no issues. And then ice from 0 to -10. Okay, so now tell me what value should I include? Tanisha.
100.
Okay.
Multiplied by 4.2.
Okay.
And 20 minus 0 minus 20.
20 minus 0 or 0 minus 20?
Into ice at 1 minus 10 degrees Celsius. So we will take.
So what should I write over here? First, complete this step.
First we will 20 minus 0.
20 minus?
0.
Okay. Then
100 into 336.
okay, 100 into 336. Next,
100 into 2.1 into 10.
so always first write this step, no? M CW delta T plus ML plus M into C of ice into delta T. M you can take out common, so then it becomes easy. So that is 100 if we take out common, then it would be 4.2. Complete and get the answer. Azra, you got the answer of this?
Sir, doing sir. वो heat extracted I am doing sir.
Okay, okay.
Sir, I got 44100 joule. Now I'm finding the heat extracted per second.
Okay, perfect.
The 44100 joules.
Perfect. ठीक है.
Divided by 60.
Divided by
60.
60. Azra, correct na? 60 you did 60?
No sir, 60 into 60.
Perfect.
Because
60 is 1 hour. So 1 hour will have 60 minutes. So 60 into 60.
sir, it is coming 12.25 watt. Joule per second.
हाँ, joule per second or watt. Both the answers are correct. Okay. Next, Tanisha, just tell me this one.
First, we will look at the change of phase.
Perfect. So what should I write?
And 40 into 336.
But steps to tell me what, according to principle of calorimetry, what should I write?
Heat lost is equals to heat gain.
Heat lost by what?
Lost by cold body.
Heat lost by?
Heat lost by hot body.
By hot body. Okay. By steam. Will be equal to heat gained by what?
Ice.
Ice. Perfect. Because they've given us steam. Okay. What should I write the next step?
8 into 2 to 6.
Okay, but first write this step, na? M into L V plus L F M into L steam, na? It's yeah. So L latent heat of vaporization, yeah, V, that is fine. Okay. Or next, what should I write?
MC delta T.
M C of what? Matlab C of,
Steam.
now steam is converted na, into water. That's why we wrote M, heat lost by steam. So steam will convert to water. So MCW delta T is equal to
MC delta T plus ML
okay. Okay. Plus
MC delta T.
okay. ठीक है. Okay. So now tell me the values.
M latent heat of vaporization, that will be 8 into 2268.
8 into 2268 plus
8 into 4.2
perfect into
100. So V is
next
equals
step.
to
100 minus T, na, that final temperature you have to find out.
and is equals to 40 into 336 plus 40 into 4.2
Okay.
into T minus 0.
Perfect. So now calculate the value of T. Azra, what you are getting the value of T?
Sir, doing so.
Okay.
Sir, T is 40
T is
degrees Celsius.
perfect. 40 is the perfect correct answer. Just try down this question. You know this question, next one?
Sir, this one.
Yeah.
Yes, we have to make the graph and show the two phase changes. First, when ice changes to water at 0 degrees Celsius, and then water changes to vapor at 100 degrees Celsius.
Okay. Try down and share me the image.
Yes, sir, I'm making.
Tanisha, how will we do this? Now, what should I do?
First, we will the temperature side.
Okay. Where should I keep the temperature? Over here, x-axis or y-axis?
Y-axis.
Okay. So temperature is on y-axis. Okay.
And time in seconds will be in the x-axis.
Okay. Now,
So first we will take ice at minus 10 degrees Celsius.
how ice at minus 10 degree? The question is not given. Where ice is minus 10 degrees given?
At 0 degrees Celsius, we need ice.
Okay. So now, because it's forming till steam. So what I will do, I will mark till 100, 20, 40, 60, 80.
Sir, should I
100.
send?
Clear?
So the ice will be heated and at 20 degrees Celsius.
Okay.
Then till 20 degrees Celsius it will be heated and
So ice, first of all, there will be phase change in phase. So from ice to water. So this, suppose this point is A, this point is B. This process is known as melting. That is change of state. At 0 degrees Celsius, ice will be converted to water.
sir, do we have to show the heated at the constant rate part? Ice is heated.
Yeah, what you are saying?
At first, I have written that some ice is heated at a constant rate.
Yeah.
So here ice is melting into water at 0 degrees Celsius. So
some ice is heated at a constant rate and temperature is recorded after till steam at 100. Draw temperature time graph to represent the change. So first ice is heated at a constant rate. So when ice will be heated, first it will convert to water. Na? So this is melting process. Now from 0 to constant heat. So 0 to 100, So now water, now this is at this point, it's water at 100 degrees Celsius. Now again steam will get converted. Na? And so now pay attention, see this graph will be a little, see this is smaller, AB is smaller, but CD, the vaporization one, is larger one.
Okay.
Here there will be no change in temperature. CD. Ajay, Azra, can you tell me why this line CD horizontal line is more than AB? Why this line is bigger?
Why CD is bigger than
What is latent heat of fusion of ice? What is the value of?
336
Unit?
joule per gram.
And what about latent heat of vaporization?
2.1.
2.1. In previous question only we did, na?
Uh, 4.2.
It is specific heat of water. I am asking latent heat. Tanisha, you know the latent heat of vaporization?
268.
2268 joule per gram. So which will have more heat, which will require more heat? During this AB, the heat required will be Q equal to ML, but the value of L is smaller. And in case of CD, MLF, and in case of CD, it's latent heat of vaporization. So value of Q will be more, na? So more heat will be required. So more time will be required, na? So that's why this will require more time. So that's why this graph is.
And yes, a specific heat capacity of liquid is more as compared to that of solid.
We are not talking about specific heat capacity. We are talking about latent heat. This horizontal line represents latent heat of vaporization. I am talking about both horizontal lines. Both horizontal lines I am talking about.
The latent heat of vaporization is more than latent heat of fusion.
Perfect. So latent heat of, so now if mass will remain same only. So if I am multiplying by mass on both sides, so we can write like this, na, QV will be greater than QF.
Okay, that's why that is
the time
bigger.
Time will be more because more amount of heat will be required. So that's why this graph is clear. So next question. Just what about the what are represented by AB and CD?
AB shows the phase change of ice to water, that is melting of ice, fusion. And CD shows vaporization, that is water converts to vapor.
Steam. Okay, next part, Tanisha.
Conclusion can you draw regarding the nature of ice?
What conclusion can you draw regarding the nature of ice from above graph?
This
Now we
ice has high latent heat of fusion.
what conclusion can you draw regarding the nature of ice from the above graph?
In from it melts at a longer rate.
Yeah, same thing we can write like this. Latent heat of ice, specific latent heat of ice is less than latent heat of water, because they are just asking the nature of ice now. So specific latent heat of ice is less than latent heat of water. So that's why the graph, matlab AB will represent a, so time taken by AB will be less than time taken by to change state from ice to water will be less than time taken by that from water to steam. So same A, B and CD, but that only, that is the nature of ice. But ice, because its latent heat is less, so melting will take quickly as compared to vaporization. Clear? Clear, or still you are having doubt?
No, sir, clear.
Clear.
Okay, let's try down one more question. So the next question I am writing over here. Heat released by m1 gram of steam to water is used to convert m2 gram of ice at 0 to water at 0. So what will be the ratio of m1 to m2? You understood the question? The heat released by m1 gram of steam at 100 degrees Celsius to water at 100 degrees Celsius is used to convert m2 gram of ice at 0 degrees Celsius to water at 0 degrees Celsius. What will be the ratio of m1 is to m2? Tanisha, tell me the steps.
First, heat released by first latent heat of steam
Okay, heat lost by steam.
plus the change of phase.
Okay, plus that is heat lost by steam during change of phase. Okay, so next.
E equal to heat gained by water.
Huh?
Heat lost by steam plus change of phase of steam.
Okay, heat lost by steam. So that's 100 degrees Celsius to water. That is change in phase only, na? So
Yeah.
steam to water at 100 degrees Celsius. Anything else? Plus the final temperature is 0, na? So plus water from 100 to 0. This will be the heat lost, and that is equal to heat gained by ice from 0 to water because the final temperature is 0. So the water from 100 to 0 will also be included.
Plus MC delta T.
Okay, so what should I write? Value. Okay, this will be MC delta T. This will
M1
M1 into L,
L.
vaporization. M2
Temperature will be
fusion. M1 into, what should I write? The latent heat of vaporization. What is the value? Tanisha, what is the value? 2268
2268.
plus M1 into, what is the specific latent heat of water? No, just specific heat of water.
Heat capacity 4.2 into 100.
4.2 into 100. Perfect. And over this side?
M1 M2 into 336.
Okay.
So ratio will be 1:8.
Perfect.